Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We're continuing with Chapter 7, which is all about systems. Today we're doing 7.6. Our name of the lesson is Solving Systems of Linear Inequalities. Our central question is, how do we graph systems of inequalities in two variables? All right, so we got a recap from Chapter 6, actually 6.5 to be specific. So basically, solutions of linear equations, solutions to systems of linear equations, that is where if you draw a graph, it's where the two lines cross, right here, basically, right? Solutions to linear inequalities, you graph like this and you draw a line, it's basically going to be shaded on one side like this, right? That's going to be a solution. And also the line could be dotted or it could be dashed or it could be solid. Now what we're doing is we're drawing two of these. We're drawing basically two lines with shaded regions, and we're going to be graphing where they overlap. Basically, the solutions are going to be, because the solutions in the shaded section, all these are solutions wherever they are in the shaded section, and all points that are not in the shaded section are not solutions. And so basically, we're going to be graphing multiple linear inequalities in the same graph, and we're going to be seeing where they overlap. Basically, that's going to be the solution here. Okay. So let's recap. So step one is to make the inequality look like slope-intercept form, which is y equals mx plus b. All right. And then to second, graph the line. It says boundary lines are going to be dashed when, so we have less than, so what are the options? Less than, greater than, less than or equal to, or greater than or equal to. When are they dashed? Well, they are dashed when it's not equal to. So it's just going to be less than or greater than. It's going to be when it's dashed. Okay? That means when they're solid, it's going to be when it's equal to, which is going to be less than or equal to or greater than or equal to. All right. Cool. Doing well so far. Okay. Step 3 says to test a point to see if you'll shade above or below. I don't like to test a point. I just like to do what I like to do this stuff down here. I think this is a lot easier. So if it's less than or equal to, we're going to shade what? Well, we're going to shade below. And that means if it's greater than or equal to for y, it's only if it's for y, though, we're going to shade above. Okay. All right, and then also, x, if it's a vertical line where it's x is less than or x is less than or equal to, we're going to shade to the left. And if it's greater than or equal to, we're going to shade to the right. Okay, so if it's a vertical line, it's a little bit different because there is no above or below. So just be aware that if it's less than or equal to, you're going to shade to the left. Greater than or equal to, you're going to shade to the right. All right, and the solution of a system of inequalities is going to be an ordered pair. An ordered pair. That is the solution of each inequality in the system, and the graph is going to be the shaded region that is true for all the inequalities. Okay? And basically what it says down here is we're going to graph them the way we were before. We're going to see where they overlap. Okay? So let's get right into it. Let's use green and blue here. So I'm going to call this one, it's going to be green. So going back to 6.5, the first point we graph it like we're graphing y equals. So the first point we graph is m or b we graph first. We graph b first. What's our b for net y is less than negative 2x plus 4? Well, it's going to be 4. So we're going to go up 4 or down 4? We're going to go up 1, 2, 3, 4, put a point. Okay. What's our slope telling us to do for that green equation? Well, it's negative 2 over 1, so we're going to go down 2, right 1. Down 2, right 1. Go all the way across if possible. We can also go the exact opposite direction, which is going to be up 2, left 1. Okay, I'm going to try to use a ruler function here and see if this is going to help me. Not done this before. I'll give it a try. Oh, and I goofed up, actually. It's going to be the first thing we should have done before we actually started graphing is we should have circled this. Is that a dashed or a solid line if it's just less than? That's a dashed line. And are we shading above or below if it's less than? We're going to shade below. So it's dashed and below, and then we're going to draw a dashed line. And this should be good. Move this out of the way. So there's our dashed line. Now you may or may not be able to see the ruler, but I have the ruler here. Okay. All right, so there's our dashed line, and we're going to shade below. Now, when we're graphing multiple inequalities, don't actually shade right away. We're going to draw some arrows. I'm going to draw some arrows. We're shading below. just going to draw some arrows to help us know which way to shade, okay? So we have a general idea which way we're going to shade, but we need to see where they overlap. We're not going to shade everything, we're just going to shade where they overlap, okay? All right, the second one is y is greater than 3x minus 4. So again, we're going to circle this. First thing we should do is see if it's solid or dashed if it's greater than. It's dashed. Above or below if it's greater than. We're going to shade above. Okay, the first point we're going to graph, is it 3 or negative 4? Negative 4, we're going to go down 4, put a point. What's our slope telling us to do? It's 3, means go up 3 over 1. Up 3 over 1, up 3 over 1. Get my ruler back here. And it's dashed, so I'm going to draw a dashed line. A little bit off, but it'll work. Okay, and now we got to mark, we're shading above. So I'm going to draw some arrows above the line here. So you can see where they overlap. We're not going to shade over here. They overlap, and that's going to be the solution. They don't shade, we're not going to shade in the top, the right, or the bottom. We're going to shade, they overlap over here. I'm going to use red and make it a little bit bigger marker. So we're going to shade over here. This is where the lines overlap. So that's going to be the solution to this system, is right over there to the left. Because it's shading below the green line and above the blue line. That's going to be the solution for both of them. Okay? All right, there's our first answer. Moving on. Get my notes ready here. All right, now we're going to go the opposite direction. So, in this case, we're given says write a system of inequalities that defines a shaded region at the right. So we're actually given a shaded region, and we have to come up with a solution for this. So let's go ahead and do this here. So, let's start with blue. We'll start with the blue line first. So, what we need to find is we need to find the equation of the line and where we're shading for the blue line. So the blue line is right over here. Well, you can see the blue line. It's the one slanting up from left to right. So we have to find an m and a b for the blue line, because that's what we need to be able to write an equation. So what's the slope of the blue line? Well, it looks like we start right here. We go up 1 and we go over 3. So what's the slope if we go up 1 over 3? It's 1/3. All right. What's our b? Where's it across the y-axis? Crosses the y-axis at 4. All right. And which way are we shading? It looks like we shade below the blue line, and we have a solid line. So it's solid, and below. So what inequality are we going to use for that? Well, below is less than, and solid means is equal to. So we're going to do this. So the equation of the blue line is going to be y is less than or equal to 1/3 x plus 4. Okay, it's always y equals mx plus b. But we found our m and b, and then we figured out what the inequality is going to be. And it's going to be y equals 1/3 x plus 4. All right, let's do the black one now. Black one. So the black one looks like we start our b, we start right here, crosses the y-axis at 2. And our m, for our m, we go here, we go down 1, right 2, it looks like. So negative 1 over 2 is going to be our m. And then what's the black line? We're going shading above the black line, it looks like. So it's going to be, it's solid and above. Which means, what kind of line do we have here? Or what kind of inequality do we have? Well, it's above, so it's going to be greater than. And it's solid, which means it's equal to. So the black line is going to be y is greater than or equal to negative 1/2 x plus 2. Okay, and then we have the red line, which is probably the trickiest one of all, but it's really not that tricky if you think about it. We have a vertical line, up and down, vertical line. It's shaded to the left. You can see it's shaded to the left. And it's also solid. So what kind of, remember vertical lines, was that x equals or y equals? It's going to be x equals, but then what kind of inequality do we have if it's solid and shaded to the left? Well, it's going to be less than, because it's shaded to the left, it's going to be equal to because it's solid. And then we're starting at the where it crosses, it looks like it crosses at 3, so it's going to be x is less than 3, less than or equal to 3. So our answer is going to be, let's write this out. We have y is less than or equal to 1/3 x plus 4. And we have y is greater than or equal to -1/2 x plus 2. And x is less than or equal to 3. This is our final answer. This is our system of equations. That was really goofy. All right, that was a little goofy. Let me see if that fixed it here. And there's our answer. Okay. All right, let's move on to the next one here. Okay, now we're doing solution region between parallel lines. Okay. So we are going to graph these two things, and these are going to be parallel lines. It already kind of gave it away, but we're going to kind of see what happens when we solve this here. So we're going to solve x plus y is less than 5. Okay, so first things first, we need y to be by itself. Is y by itself right now or no? It's not. So how do we get y by itself? Always subtract x from both sides. Get y is less than -x plus 5. All right, let's graph this now. Y is less than -x plus 5. What's the first point we're going to graph? We're going to graph the 5. We go up 5. 1, 2, 3, 4, up 5. What's our slope in front of the -x? Well, that's going to be -1. We're going to go down 1, right 1. We keep going down 1, right 1, all the way as far as we can go. And we go back to the opposite direction and go up 1, left 1. See if we can get the ruler to work this time nicely. Okay, let's see if this wants to work. And it's going to be, oh, I goofed up again. So we have to circle this. This is a solid or a dashed line if it's less than. It's dashed. And is it above or below if it's less than? It's below. It's dashed and below. We always have to do that first. So it's going to be a dashed line. So there's our dashed line. Dang it. And we're shading below. We're not going to shade yet, though. We're going to draw some arrows going straight down here. So no, we're going to be shading below, but we don't know where it's going to overlap yet. All right, let's do the blue line now. So now we have y is greater than or equal to -x minus 4. What's the first point we're going to graph? We're going to graph -4. We're going to go down 4. 1, 2, 3, 4. And our slope, again, is the same thing. These are parallel lines which have the same slope. So we're going to go down 1, right 1. So -1 over 1. Go up 1, left 1. And again, we have to look at this here. This is going to be a solid line because it's equal to, and it's going to be above. Solid and above. So this time I can just draw. I can just draw a nice straight line. That was not good. Not going to be perfect, but it'll work. All right, and this one we said we're shading above, so we're going to draw some arrows going straight up and above. You can see where they overlap now, so now we can use red. Make it a little bit bigger. And we can see we shade right between these. Below the green line, above the blue line is going to be shaded between. Okay? All right, I think we have one more example, and this one's probably the hardest one, but it's basically we're just doing, we're graphing multiple inequalities, and it's going to be just kind of putting together a shaded region of multiple inequalities. So we're going to break it down a little bit by a little bit, but don't panic. We will get through this okay, all right? All right, so first one we have is x is greater than or equal to 1. First of all, is it in y equals mx plus b form? It kind of is. When you just have x, it's just going to be x by itself, which is fine. So this one, is it going to be solid or dashed if it's equal to? It's solid. And is it above or below? Or actually, is it left or right if it's greater than? This one's to the right. Remember, trick to this is that it's pointing to the right, which means it's going to shade to the right. Okay, so it's going solid and shaded to the right. So we're going to go to a vertical line through x equals 1. So let's go ahead and do that. Vertical line through x equals 1. And there's our vertical line, and we're going to be shading to the right. So we're just going to draw some arrows all the way across here. Okay, so that's kind of the start of it. Let's go ahead and do a red line now. Now we have x is less than or equal to 4. Is that solid or dashed if it's equal to? That is solid. Is it left or right if it's pointing to the left? It's to the left. So we have to go to x equals 4. 1, 2, 3. Here's 4. And we're shading to the left. We're going to draw some arrows to the left. So you can kind of see as we're shading between the two areas right now, between the lines, but we still have 2 more graphs we have to do. All right, here's blue. We have y is less than or equal to -1. First of all, is that solid or dashed? That is solid. Above or below if it's greater than and above. Solid and above. So this is going to be this is y equals, there's no x. It's not going to be like x plus 2 or whatever. This is a horizontal line. If you recall from Hoy-Vox, it's y equals. It's a horizontal line through y equals -1. So we're going to go to y equals -1. We're going to do a horizontal line, solid. And we're shading above. Now, I could draw arrows to the left over here, but we have to be between the 2 lines and above the blue line. So I'm just drawing an arrow straight up right here from the blue line. Okay. Last one we have is the green line. We have y is less than or equal to 1/2 x plus 1. First of all, is this going to be solid or dashed if it's equal to? It's solid. And above or below? It's below. All right. Okay, so this one we have to graph this like we normally would. So it's going to be, our b is 1, so we're going to go up 1, put a point. And our slope is 1/2, so we're going to go up 1, right 2, up 1, right 2, up 1, right 2. And you can also go down 1, left 2. And it's going to be a solid line. Can't get a straight line here too good, but that's okay. There's our straight line, and it's shaded below. So it has to be to the right of the black line, to the left of the red line, above the blue line, and below the green line. So we're going to go right here. And then we need, I think we can do, what is that? I don't know if I did the right thing there. Okay, so we're going to we'll use this pink here. We're going to shade. We'll make it kind of like we're highlighting. And we want to do probably like this. Okay, so it's going to be this area right here. All right, and that's the overlapping region between all the lines. It's below the green line, to the right of the black line, to the left of the red line, and above the blue line. All right, that was a hard lesson, but thank you for getting through it and doing your best work. I think the quiz will probably not be as hard as some of these, but it's good to go through some of this stuff and make sure we understand it. So thank you for watching. Have a great day. We will talk soon.